There are a lot of identities other than the fundamental identities. We won't be memorizing all of these, but we do need to learn to verify them, in other words, to prove that they are true. The technique you'll use is to start with the more complicated side and use algebra and the fundamental identities to turn it into the other side. Do not work with both sides at the same time, except on scratch paper. For example, let's verify the identity cosecant times cotangent of theta equals secant of theta. So I start by writing down the left-hand side because that's the more complicated side. And you do need to actually write it down. Don't make your reader guess which side you're starting with by not writing it down. Anyway, I'll then use the fundamental trig identities to write cosecant as 1 over the sine and to write tangent as sine over cosine. Then the sines cancel, so now I'm using algebra to simplify, leaving me 1 over the cosine of theta, which is equal to the secant of theta. So again, you start by writing down the more complicated side. You use fundamental trig identities and algebra, and you should wind up able to write down the other side of the trig identity. All three of those parts are important. Something not to do, as I said in the note above, is not to work with both sides at the same time. So your work should not look like the original identity on both sides and then, for example, turning cosecant times tangent into 1 over sine of theta times sine of theta over cosine of theta, and then saying that's equal to the other side, which you could write as 1 over cosine theta, and then simplifying and saying, hey, I get 1 over cosine of theta, and that is certainly equal to 1 over cosine of theta. So do not work with both sides. That's what not to do. You may be wondering what's so terrible about working with both sides, because it does seem kind of a natural thing to do. And honestly, if you want to go off on scratch paper and work like that, I don't care. But your work that you turn in should not look like that. And here's the reason. You give the appearance of circular reasoning. Circular reasoning is when you're trying to prove something is true and you start out by assuming it's true and then build on that assumption to show that it's true. For example, I can prove that today is Friday, regardless of what day it actually is. I can prove it's Friday like this. Assume today is Friday, then tomorrow is Saturday. But if tomorrow is Saturday, then today must be Friday. See, that's silly. If I start out by assuming it's Friday, of course I can prove it's Friday. And that's what you want to not give the appearance of doing. If you're trying to prove cosecant times tangent equals secant, you cannot start out by asserting that they're equal. All right, let's go on. Let's prove the identity sine of theta over 1 plus cosine of theta plus 1 plus the cosine of theta equals 2 times the cosecant of theta. So I start by actually writing down the left-hand side, sine of theta over 1 plus cosine of theta plus 1 plus cosine of theta equals sine of theta. I'm not doing any simplifying when I write it down. I'm just writing it down in its exact original form so that it's very easy for the reader to see where I'm starting. In the next step, I will start simplifying. The LCD for those two fractions is sine of theta times 1 plus cosine of theta. So I multiply the first fraction by sine of theta over sine of theta, and then I have times sine of theta over 1 plus cosine of theta plus, and I'm going to multiply the second fraction by 1 plus cosine of theta over 1 plus cosine of theta, and then that's times 1 plus cosine of theta over the sine of theta. Multiplying the denominators and adding the fractions, I get sine squared of theta plus the quantity 1 plus cosine of theta, the quantity is squared, that's over sine of theta times the quantity 1 plus cosine of theta. Be careful that you don't try to cancel now. That's a common mistake, but we're not allowed to cancel because of this plus sign in there. What I need to do is square out that 1 plus cosine of theta, simplify, and factor, and then maybe I'll be able to cancel. I don't know. We'll see. Let's square out the 1 plus cosine of theta. I will use the formula a plus b squared equals a squared plus 2ab plus b squared. That will give me sine squared of theta plus 1 plus 2 cosine of theta plus cosine squared of theta over sine of theta times 1 plus cosine of theta. Notice that there's a sine squared plus a cosine squared. That's something to always watch out for, because sine squared plus cosine squared equals 1. If it helps you to move that cosine squared over next to the sine squared, that's fine, but I'm not going to bother to do that. Now I have, notice the cosine squared and the sine squared are gone because they add up to 1. So here's the 1 that used to be sine squared plus cosine squared. The other one is the one that was already in the numerator. So now I have 1 plus 2 cosine of theta over sine of theta times 1 plus cosine of theta. And of course 1 plus 1 is 2. I can factor out that 2. That will give 2 times 1 plus cosine of theta over the sine of theta, I forgot the theta there, that's important, times 1 plus cosine of theta. The 1 plus cosine of theta cancels. Notice that our numerator and denominator are both factored now, so the things we're canceling are factors, not terms. That gives us 2 times the sine of theta, which is equal to 2 times the cosecant of theta. And that was the right-hand side that we were hoping to wind up with, and we did wind up with it, so we're done. I'd like to point out another thing not to do. So here's our identity again. In this work, I have not written down the original exact left-hand side. I've just launched into doing things to it. And that is not the proper form. We have to write down the original side. Without doing anything to it. it's also not proper form to just put an arrow up to it. You need to actually write it down. Next, let's establish the identity secant of theta times cotangent of theta minus sine of theta equals cosine squared of theta over sine of theta. In this one, both sides look kind of complicated, but I'm going to start with the left-hand side for two reasons. First of all, it's a subtraction, and it seems more natural to simplify that as opposed to trying to take the right-hand side and split it up somehow into a subtraction. The other thing I notice about the left-hand side as compared to the right-hand side is the right-hand side is all cosines and sines, whereas the other side is not. And it's more natural. I have more practice at turning things into sines and cosines as opposed to trying to take sines and cosines and turning them into something else. You can start with either side, it doesn't matter, but to me it looks easier to start with the left-hand side. So I'm going to actually write down the left-hand side in its original form without doing anything to it. Then I write equals. And by the way, I haven't mentioned this, but these equal signs are important too. They're like the verb in a sentence. They're explaining the relationship between all these things I'm writing down. I am claiming that they're all equal. And if I don't put the equal sign, that's not clear. Okay, back to the problem. I rewrite secant as 1 over the cosine of theta. I rewrite cotangent as cosine of theta over sine of theta. And I still have the minus sine of theta. The cosines cancel, leaving me equals 1 over the sine of theta minus the sine of theta equals. I need to perform that subtraction, and I need an LCD for that. The LCD is sine. So I still have my 1 over sine of theta. I don't need to do anything to that. But that minus sine of theta, I need to multiply by sine of theta over sine of theta. Now I have 1 minus the sine squared of theta over the sine of theta. 1 minus the sine squared of theta, hopefully you recognize as cosine squared of theta. That's a version of that identity, sine squared plus cosine squared equals 1. And then we have over sine of theta. That's the right-hand side of the identity we were trying to prove, so we are done.